Welcome to 4-4 homework problems. Use this wisely. Hopefully we're checking answers. We are still finding dy dx. This is the end of the first section of 4-4. Goes through 26. We have new derivative rules, and one of those tells us that this is another snippet. Derivative of ln of a function, could be some function of x, equals 1 on the function times the derivative of the function. That is the chain rule. We're taking the derivative of the baby. So this actually, wish I'd have drawn that a little bit cleaner. It has an ln x, but the outside derivative is something squared. So this is a chain rule. dy dx equals the outside derivative of the inside function times, so this is to the first, times the inside derivative, but derivative of ln x is just 1 on x. So back of the book answer should be 2 ln x on x. dy dx equals, there we go, not much to it. 18. Y equals, just specializing in ln's right now, ln of 10 on x. And we may want to think of that as ln of 10x to the negative first, because I know my inside function, I'm going to want that inside derivative at some point. I like taking it in this. You could quotient rule it from here. So dy dx, my outside derivative, 1 on, of the inside function, 10x to the negative first, times the inside derivative, the derivative of 10x to the negative first, is negative 10x to the negative second. So let's clean this up a little bit. I get equals, this x is coming to the top, x to the first, this 10 is staying on the bottom, times this negative 10 stays on the top, it's not affected by the x to the negative second. This x to the negative second goes to the bottom, and I get negative 10's cancel, x to the first, x to the second. I end up with an x in the denominator and a negative 1 in the numerator. Dy dx, kind of an interesting result, where the 10 actually ends up not really becoming a player because it's a player in both of these. Okay. Anyway, let's take a look at number 20. Number 20 is x ln x minus x. That's y equals dy dx. Product rule. Every time I get a product rule, I'm writing parentheses whether I have to or not. Excuse me as I adjust the paper. And still dealing with ln, so pull my little snippet down here, still in play. Dy dx, first times derivative of second. Derivative of ln of x, 1 on x, plus plain old first 1. Excuse me, derivative of first 1 times ln x minus derivative of x, 1. So I end up with x times 1 on x is 1 minus 1 ln x dy dx. It's almost magic trick. Alrighty. Let's take a look at number 22. So far this assignment's looking a little bit easier than the last one. I'm sure it's going to get a little tougher soon. Here we have y equals log base 5 of square root of x, which we may want to think of as log base 5 of x to the 1/2, because I know somewhere down the road this is going to be a baby function. Let's see. New snippet, the word for the day. Log base a of u. Well, if this was ln, it would just be 1 on u. But since it's not ln, we have to adjust for that with an ln of what base it is. This is sort of like change of base formula. So I'm log base 5, so my derivative with respect to x becomes, it wants to be 1 on the argument. and the argument is square root of x. But I have to adjust that with ln of base A, ln 5. That's how I compensate for it not being e. And I still have to multiply by the inside derivative, which is 1/2 x to the negative 1/2. So what do we end up with? Can we do this in one step? Numerator, 1 stays in the numerator times 1, 1. X to the negative 1/2 goes down to the bottom, becomes x to the 1/2, but x to the 1/2 times square root of x is just x ln 5. All right. 24. Take a bunch of these guys on the test. Number 24, here we have y equals 1 on log base 2 of x. And I could treat this like a quotient rule. I could also treat this like log base 2 of x to the negative first. And I think we're going to get there either way. That would be your challenge. Go ahead and try this a different way. I'm going to work with this guy. dy dx, my outside derivative is negative 1 of my inside function log base 2 of x to the negative second times my inside derivative. But my inside derivative is not ln, it's log base 2. It still wants to act like ln, 1 on the argument, 1 on x, but I compensate with ln of our base 2 times the inside derivative, but the inside derivative is x. So let's clean this one up. I get negative 1 times negative, my only numerator is going to be negative 1. Then I get x with log 2x times ln 2 in the denominator. I have a squared here as well. Almost missed that. That would come down as squared. Hope you see that one sticking in there. So negative 1 on x log base 2 of x squared ln 2. And number 26, I got a bell going to ring in a minute here, so we might go through the bell on this one. We've got y equals log base 3 of 1 plus x ln 3. Of course, they'll give me that one when I have 1 minute left. Let's see how this goes. dy dx. Log, the derivative of log, it wants to be like ln x, which would be 1 plus x ln 3, the argument, but I have to compensate with ln 3. It's not that, and I need the derivative of this. And the derivative of this guy is a product. Oh, is it a product rule here? No, this is a constant times, and constants survive. That's ln 3. It's just ln 3 times x. Holy cow, this one worked out quicker than I thought. 1 on 1 plus x ln 3. Now, we should be making some type of comment about values of perhaps what x can be, because we have some potential domain issues in here. See, there's no domain issues here, and now it doesn't look like there's really domain issues. So we may need to say something along the lines as x ln 3 should be plus 1 should be greater than 0, or x is greater than negative 1 on ln 3. Would be a nice attachment to this problem. So there is through 26 and more to follow. Thank you.